Good morning. Today we are starting off with 9.1, which is adding and subtracting polynomials. So what is a polynomial? We're going to get there. We're going to talk about some vocabulary first. So first, a monomial term. Mono is a prefix meaning one. So there is only one term in a list of x's and y's and numbers. A binomial, just like a bicycle, has two wheels. A binomial has two terms. Then as we go on, a like a tricycle or a triangle, has three sides or three terms. And then a polynomial you would think would be four, but poly just means many. A polynomial is just many terms. Oops, T-E-R-M-S. So many terms would be anything probably more than one. It could be two, it could be three, but we use the word polynomial to describe more than one term here. So here's an example of a polynomial. We have a variety of terms here. Every grouping together with a number and a letter is considered a term. This is a term, this is a term, this is a term, and this is a term. So this has 1, 2, 3, 4 terms. If you notice, there's some words here. We always list them from the highest degree to the lowest degree. So from high to low, meaning the degree is our exponent. So this has a degree of 3, this has a degree of 2, this is really x to the power of 1, and this doesn't have any x's. So from the highest x's to the lowest x's. The leading coefficient is just the number that's out front. This would be a 1, this would be a -5, and that's just a 12. And then a constant term is just any term that doesn't have an x. So you notice there's an x here, an x here, an x here. This one doesn't, it's just a number. It's always going to be 12. It's never going to change. So that's just some vocabulary, some information you're going to want to know as we go through adding and subtracting polynomials from each other. So it says find the sum meaning adding, or difference meaning subtracting. We have two big sets of parentheses. This polynomial we're going to add to this polynomial. So thinking of adding as you're going to the grocery store and you have one basket and you're combining it with another basket. You're simply just putting all the fruits and vegetables into the same basket. None of the exponents are going to change. The oranges are still going to be oranges, and the apples are still going to be apples. Okay? We're not making a smoothie. They're still going to stay the same. So we're just going to combine the terms that have the same exponent. So this exponent right here has to the power of 3, and this exponent right here, this term, has the exponent or the power of 3. So if we put these in the same basket, we have 2x to the thirds here and 1x to the third here. So if we're just adding those together, we now have 2 plus 1 more is 3x to the thirds. Our leading number in front just tells us how many we have. So if these were apples, we have 2 apples and we have 1 more apple. We now have 3 apples. Okay? And I'm doing this in a specific order from our highest degree, highest exponent, to the lowest exponent. So then I'm going to look for our exponent of 2. Be careful, this negative goes with the 2. We have a -5 there and a +2 here. If we put those in the same basket, a -5 plus 2 more is only a -3, and x to the squared. Our x to the squareds didn't change. We just put them all in the same basket. And then this is the only one that has just an x, so that's 1x. So I'm just going to write that. There's just one of those there. And then last, this is just a -1. There's no number with it or no letter with it, so it's just -1. So this is our answer. We combined all of our like terms. All the ones that had x to the 3, all the ones that had x to the 2, and then just the leftovers. So let's try another one. This one, we have this basket, but we're going to subtract or take away this basket. So if we're going to subtract this whole basket, we have to subtract this piece, and this piece. So we're really distributing everything by -1. So I'm just going to rewrite this. -1 times 3 is -3, just multiplying the numbers. A negative times a negative makes a positive x, or positive 1x. And then a negative times a negative, again, makes a positive 8. So I'm just going to cross this out because I already distributed that negative. Now we're just going to combine or add our baskets together. We're going to start with the highest exponent, the x squareds. So 4 minus 3 gives me a 1x squared. We had 4 here and 3 here. Then just my x's, I have a negative 3x and a positive 1x. Negative 3 plus 1 is negative 2x, combining those together. And then I have plus 5 and plus 8, combining those 8 plus 5 should give you 13. So this is our polynomial. We found the sum and the difference here. Alright, we'll do one more like this. This one also, we're subtracting this basket from this basket. So we're going to subtract or distribute all of these. We're subtracting every single one. So here a negative times a negative makes a positive 13b squared. A negative times a negative, and we're multiplying, remember, because they're touching right here. Makes a positive 5b. And a negative times a positive makes a negative 14. So I don't need this piece anymore. We're going to combine our two groups. Here this one has b to the power of 3. Now we have to be careful on this one. This is the only term that has the power of 3. So 9b to the third. And then we have our b squared. So we have a negative 13b squared here and a positive 13b squared here. Well, negative 13 plus positive 13 makes 0. So those ones actually cancel out. There's no b squareds left over. It's like having, you're owing someone 13 and now you have 13. You're now evened out at 0. And then we have just our b's. This is 1b and this is 5b. So total 1 plus 5 gives me 6b. And then just our number there in the end, we have a negative 14. So this is our polynomial. A couple more like this. Again, this one is adding, so we're going to combine our like terms, combining this basket with this basket. Remember, none of the letters are going to change. Be careful though, here we have x squareds, we have xy's, and we have y squareds. Always go in alphabetical order. If you have two letters, like this one is here, we start with the highest degree and go down to the lowest for x's first, like x squared, and this would be x to the power of 1 and y to the power of 1. And then going backwards, the y to the power of 1 and then y squared, going the opposite direction. So let's combine these together. I have a 3x squared here and a negative 5x squared here. Well, 3 minus 5 gives me a negative 2x squared. Then I have just my xy's. This is 1xy here and a negative 4xy here. 1 minus 4 is negative 3xy. And then my y squareds. I have a negative 6y squared and a positive 8y squared. Negative 6 plus 8, there's more positives. 2 more, so 2y squared. And this is my answer. We've combined our like terms. This next one, you have to be super careful. Like I said, we always go in alphabetical order, x's and then y's. In our term here, we always go in alphabetical order as well, x and then y. If it's not in alphabetical order, we'll have to flip some things around. So I'm just going to check as I go across. 6m squared n, this would be to the power of 1. 5mn squared, so this is 1m and 2 n's. 8n, 2m. Then we're just going to subtract all two terms here, or multiply each one by a negative. Be careful here. This one says n squared m. We have n's first and then m's. And when you think about alphabetical order, we go L, M, N. So we actually have to flip these letters around. So this should be the m first, and then the n squared. This is 1m and 2 n's. So I flip that around, and now it's a negative. This one's also going to be a negative 3. And then the m's are in order here. L, M, N. Right like that. M, N. So now we can combine our like terms. Starting with the m's first with the highest degree of 2. I have 6m squared n's and a negative 3m squared n. I'm combining these together because they have the exact same letters, m squared n, m squared n. So 6 minus 3 gives me 3m squared n. And then I'm going to do the ones with just one m. So here's a negative 6m n squared and a negative 5m n squared. We have one m and two n's, one m and two n's. So a negative 5 and a negative 6 is negative 11 m n squared. And then we just have m's and n's. M's come first still, so we have plus 2m. And then last, this one term here is minus 8n. This one has 4 terms still because there are only 2 that had like terms that we could combine. Alright, last one. Just adding up our p's here. It's a plus, so we really don't need to do anything to the second term, just combine our like terms. Starting with the highest degree to the power of 3. 7p to the third minus 6p to the third, or negative 6 plus 7. Either way, there's one more positive, p to the third. Then p squared, 9p squared minus 3p squared, 9, and then subtract 3 gives me 6p squared. Then just our p's, I have a negative 11p, and then I have 3 plus 4 gives me 7. So here's my final answer. So that was all adding and subtracting, like adding 2 baskets together. It doesn't really change what you have. You just have more or less of the same thing. Now when we're finding the product or multiplying polynomials, this is where we're making a smoothie. What we have is physically changing. Instead of just having apples and oranges, we're going to make apples and oranges together, a smoothie together. Or instead of just having x here and x here, we're going to combine that to make x squared, because x times x would give us x squared. 1x and one more x will be x squared. We're changing and making something new. We don't just have 2 x's. That's what we would get if you add. X plus x would give you 2x. But x times x, just like when we did exponents, we view x to the power of 2. So we're going to do what we learned with distributing at the beginning of the school year, but do it now to find the product when we have more than one term. So out front here I have an x, this is really a 1x, and that's multiplied by this whole piece. So I'm going to use this box to help me multiply. I'm going to put the 1x out front, and then whatever I have on top, up here we have 7x squared and a 4. And think of this inside here as everything on the outside is going in and making us a smoothie. So we got to combine these two, we got to multiply them, and we got to combine these two, we got to multiply them. So if I multiply just our numbers first here, 1 times 7 is just 7. X times x squared, this is 1x here, and this is 2x's here, so we have a total of x to the power of 3. We made a new term inside here, dumped it all in, made ourselves a nice smoothie of 7x to the third. Sounds delicious. Then we have to multiply 1x times 4. Well, 4 times 1 is just 4, and there's only 1x here, so there's still only 1x. So our answer is 7x to the third plus 4x. You can't combine these because the x's are not the same term, same exponent. So let's try the same thing over here. We have 2x to the third, and we're going to combine it with x to the third, 3x squared, a negative 2x, and a plus 5. We're going to dump these two in this little smoothie bin here, and 2 times 1 gives us 2. Here we have x to the third and another x to the third, while total we have x to the 6th. When you multiply, remember we're just adding our exponents. 3 plus 3 more gives me a total of 6. Then 2 times 3 here now multiplied make a positive 6. These are touching, that's why we're multiplying. And then 3x's here and only 2x's here will give me 5x's in that smoothie. And then a 2 times negative 2 is negative 4. 3x's here and one more here makes a total of x to the 4. And then last, 2 times 5 is 10. and then there's x to the third. So my answer, we can just write everything that we had in each of our containers to make our smoothie. We have 2x to the 6th plus 6x to the 5th minus 4x to the 4th plus 10x to the 3rd. You can't combine any of these terms because they all have different exponents. They're all different smoothies. So let's try a couple more. Whichever term is only one term, like 5xy, there's no pluses or minuses in here, that's what we're going to write out front. 5xy. You can think of this as one term by 1, 2, 3 terms. I'm going to put the 3 terms across the top. X squared minus 4xy, and then plus y squared. So we're going to multiply or combine in each bin or each container here. 5 times 1 is just 5. Now be careful, alphabetical order, we have 1x here and 1y here. So this 1x combined with these 2 x's makes x to the third, but there's still only 1y. We have 3 x's and 1y in that bin. Then in the middle one, 5 times negative 4 is negative 20. We have 1x here and 1x here. Now we have 2 x's, or x squared. And 1y here and 1y here. Now we have y squared. And then in our third container, we have 5 times 1, which is really just 5. There's only one x there, x. There's one y here, and there's 2 y's here, so that's a total of 3 y's, or y to the third. So my answer here would be 5x to the third y minus 20x squared y squared, and then plus 5xy to the power of 3. So here the x's are to the power of 3, here the y's are to the power of 3. We don't have any like terms, so that's our answer. Now let's try another one with just x's and y's as well. Our one term out front, you could put in parentheses, you don't need to there, is negative 3x. And then we have a 2xy and a 5y. So 3 times 2 is negative 6. Here's 1x, here's 1x, that makes now 2 x's, or x squared. X times x is x squared. And there's only one y there. Negative 3 times 5 is negative 15. There's an x, and there's a y. So my answer is negative 6x squared y minus 15xy. Alright, here we have now 3 terms. 1, 2, 3, multiplied by only 2 terms. We know it's multiplying because these are touching. Think of this as going shopping for a very large family. You're making 1, 2, 3, 4, 5, 6 smoothies because you have 3 terms here. You have b squared plus 6b minus 7, and you're multiplying it by this other side, which is 3b minus 4. The minus, make sure, goes with the 4. So then we're going to multiply and make these 2 terms now into 1, combine it all up, blend it up. This is really a 1b squared, so 3 times 1 is 3. b times b squared, this is 2b's and this is 1, so now we have b to the third. Then 3 times 6 is 18. 1b here and 1b here, this makes b squared. And then 3 times negative 7 is negative 21, and there's b there. Then on the bottom row, another whole row of smoothies here. We got negative 4 times 1 is negative 4. There's a b squared, so we got to write b squared. Negative 4 times 6, well, 6 times 4 is negative 24. And there's just one b from up top there. And then negative 7 times negative 4, a negative times a negative makes a positive. And 7 times 4 is 28. So now instead of just writing each of these out, we have some smoothies that we made that were identical. So if they're identical, we can actually combine them and put them in the same container, the same group. This 3b to the third is the only one with an exponent of 3, so we can just write that one. Then we have these b squareds and these b squareds, which we can combine together. An 18 and a negative 4, well, 18 minus 4 gives me 14 b squareds. So this is where we're combining the ones that are the same. The 18 and the 4 go together, but the b squared, the smoothie, stays the same, still b squared. Then our next group here, we have a negative 24b and a negative 21b. They're all both just b's, so combine them together. A negative 24 and a negative 21 gives me negative 45b. And then last, this is just plus 28, so just plus 28. So we made 4 different types of smoothies. We combined the ones that were the same. Now we have, again, 3 terms by 2 terms. The 2 terms are going to go on the side that we can fit 2 terms, so 2y minus 3. And on top here we have 3y squared minus y plus 5. This is really a 1, so I'm going to put a 1 there. And then we're going to multiply. 2 times 3 is 6. Y times y squared, we have 3y's, 1 here and 2 more, that's y to the third. 2 times negative 1 is negative 2. We have 1y here and 1y here, so we have y times y is y squared. 2 times 5 is 10, and then there's just a y. Negative 3 times 3 is negative 9, but there's a y squared, so we have to write y squared. A negative times a negative here makes a positive 3. There's just a y, so we need to write that y again. And then negative 3 times 5 is negative 15. No y's on that one. So we made our smoothies. We got to combine the ones that are the same. These two are going to be the same because they both have y squareds. And these two are going to be the same because they both have just a y. So first, 6y to the third. Then I have negative 9y and a negative 2y. Same sign, add them up. That's a negative 11y squared. Then 3 plus 10 gives me 13y. And then down here at the end we just have minus 15. So we combined all of our like terms. Here are a couple more, just 2 by 2. 2 ingredients here, 2 ingredients here. Got to combine them together and make our smoothies. It doesn't matter which one you put where. If you want to put x minus 4 on the top and then 3x plus 2 on the side, you can. If you flip-flop those around, that's fine. As long as this whole term goes together on the top and this whole term goes together on the side, or vice versa. So this is a 1, so we know 3 times 1 is 3. X times x gives us 2 x's, or x squared. 3 times negative 4 is negative 12 with an x. On the bottom, 2 times 1 is 2 with an x. And 2 times negative 4 is negative 8. So this is the only one that has an x squared, 3x squared. Our x's, we have a negative 12 and a positive 2. Well, there's more negatives, 10 more. So negative 10x. And then last, minus 8. Then over here, same thing. It doesn't matter which one you put on which side, so I'm going to write 4b minus 5. And over here, b minus 2. As long as this piece is together on this side, that's fine. Or this side. So this is really a 1. 4 times 1 is 4. b times b is b squared. Then over here, 4 times negative 2 is negative 8 with b. 5 times 1 is just negative 5 still with the b. And negative 5 times negative 2 makes a positive 10. So if you wanted to write this all out, you could write 4b squared minus 8b minus 5b plus 10. But if you'd prefer, like this last one, to combine our terms as we go and combine these two, that would be a good idea as well. Because we really have 4b squared. These really make a total of negative 13b, negative 8 and a negative 5, and then plus 10. These first two terms didn't change, just the last two. Or, I'm sorry, not the last two, the middle two here. So that's our answer. I would like for you to try these two on your own, and then click play to see if you got them right. So I wrote out my terms here. This is really a 1a. 2 times 1 is 2. 8 times a is a squared. Here, don't add, we're multiplying, making a smoothie. That gives us 6 with an a. Here, 1 times 1 is 1 with an a. And then 1 times 3 is 3. So I'm going to combine these like terms as we go, but write the biggest exponent first. 2a squared. 1a plus 6a gives me 7a. And then plus 3. Last one, I have 8t plus 11, 6t minus 1. 6 times 8 is 48. T times t is t squared. And then I have 6 times 11 is 66t. 8 times negative 1 is negative 8t. And then negative 1 times 11 is just negative 11. So we need to combine our like terms there. We have 48t squared. 66 minus 8. Well, 66 minus 10 would give us 56, but 2 more would give us 58. 58t. You could also use your calculator there. And then minus 11. Alright, there are a couple like this on your homework, so I do want to make sure you know how to do these. It says write a polynomial that represents a perimeter of the figure. Well, perimeter simply means to add all the sides. So we're simply just going to add them all up. If you wanted to write them all out and list one term plus the next term plus the next term plus the next term, you could. But we're just adding them all up. So I'm just going to combine as we go. We're adding this x, this x, this x, and this x together. So total we have 2 plus 4 gives me 6. Plus 1 more is 7. Plus 2 more, 7 plus 2 is 9 x's. We're just adding, like our grocery store, putting them all in the same cart, same basket. And then our single terms here, we have a negative 3 and a negative 1, makes a negative 4. But plus 1 is negative 3. Negative 3 plus 2 is now a negative 1. If that's confusing, think of combining these two. 2 plus 1 is 3. Well, positive 3 and negative 3 really cancel out, leaving us with just that negative 1. So that's our answer. Down here, same thing, but instead of perimeter, we're finding the area, which is multiplying base times height, or length times width, but only of this shaded region. We did one like this a couple chapters ago. It's like a picture frame. We only want the outside. So the whole thing, if we wanted the area of this whole piece, would be 12 by 8, or 8 times 12. But then we're going to take away this middle piece in here, and the base times height of that would be 2x is our base, times our height, which is x plus 1. Well, I'm just going to multiply 8 times 12. This should give us 96. And then we have to subtract 2x times x plus 1. Well, we just learned that if we have parentheses here, this part here, we need to make a box to multiply. We have a negative 2x times x plus 1. We're multiplying negative 2 times 1, which is negative 2. X times x is x squared. And same thing here. That's a negative 2, and there's just an x. So really, we have 96 minus 2x squared minus 2x. This is technically as far as we can go. However, we need to combine our like terms, or not combine our like terms, put them in order from highest degree to the lowest. So x squared is our biggest exponent, so that would come first. Then just our x's minus 2x, and then plus 96. So this gives us the area of the shaded region. We don't know what x is, so we can't figure it out entirely, but this is as far as we can get. Alright, your homework is worksheet 9.1 and 9.2, but you only need to do the odds on the entire thing. So only do the odds. You can cross off all of the evens. Good luck!